Okay, very good evening, students. Uh, so in the yesterday's class, we have stopped up to here, where we will be knowing more about ourselves by using this IoT concept. So that we discussed. Today we will discuss about the rest of the things. Probably I would like to cover the all theory sections within today. So the one thing is that thought controlled computing. So most of you have browsed through YouTube, in the sense you can be able to get this relevant data, and this is an booming technology where your thoughts can be easily understood by your system, so that it will do whatever the things you want to do. Say for example, if you wish to browse for some pictures, or if you wish to log into your system by using some passwords and keywords, then there is no need to touch up your keyboards and your mouses, and simply by thinking of that particular thing, automatically it will be converted into a electrical signal. So there is a device that will convert your brain waves into an electrical wave, and so that your computer can understand whatever the process that you want to make it in that computer system. Okay, so this is easily done. This is called thought controlled computing, and this is nowadays booming. So even without touching your mobile phone or your browser or your computer, you can able to control over your appliances. So this would be very helpful for your old age peoples, that they were in the home, so they can able to easily control the appliances, home appliances, and whatever the help they were need, they can able to easily get it soon. Okay, and also those who are not able to talk, the deaf and dumb people, they were not able to get their findings, right? So whatever the requirements for their purpose, they cannot able to do, because they cannot able to communicate. But with this device, computing device, thought controlled computing device, they can able to talk each other as like other human beings. So this is an another one booming technology nowadays that we are going to use soon. So next one is just an recollection of another one way of defining your IoT. So we have seen so many definitions, but in addition you can have this one for your refreshment of concept. So where the IoT is a network of physical objects interconnected through some various network technologies. So it is not a single technologies. We may have various different kind of network technologies, and from this the physical objects will be communicating among themselves and also with the external environment whenever there is a necessary, and through some embedded sensors, actuators, and other devices that can able to easily collect or something like transfer information about that object. Okay, and this is an internet of things that facilitates your interconnection of end user devices and underlying communication devices. This is another way of representing your IoT. Now it's time to recall all those things, whatever the importance of this particular IoT is. So there is a report saying that in 1900 your 3 lakhs depths of computers were connected to the internet, so in those years. But in 2020s, you know, this will be grown up to 300 plus millions of desktop computers, or the laptops, or the smart devices that we are having. In 2016, that you can still imagine that it is 2.5 billions of mobile phone that is connected to the internet. And if you see for today's calculation, it is about 4 billion kind of device that are going to be connected to the internet, and roughly about 500 millions of wearable watches, shoes were connected to the internet, and hundreds of millions of implants in humans or animals would be talking to each other via the internet because of this particular technology. So we can expect anything that can be easily done with the help of this IoT. So nothing is impossible here. So you can see some of the examples. When you are about to wake up, the water heater would be ready, and that will make you a hot water ready for your bathing. And during bath, your kettle would be cooked food for consuming after bath. And when you are locked the door, the car door shall be automatically opened for you. It is like a servant that is available in your home. and your AC shall be adjusted based upon your body temperature according to your need that we discussed, and your parking slot shall be informed while nearing the office itself, or while nearing any particular city or any new places that you are visiting, and your pillbox shall be alerting you the time of your tablet intake. This is a medicine reminder kind of thing, which will communicate the information to you through phone or voice call or something like alarm messages likewise. And while nearing your home itself, your light shall be turned on, or your AC shall be turned on, or your garage door will be automatically open likewise. And you will be having some workout room lights or ambience shall be controlled easily. And if you want to, you can refrigerator also will be connected. Your bedroom's AC shall be automated. So these things we discussed, right? So these are all possible. Nothing is impossible that you have to keep in mind. So anytime, any device or anyone or any service or any business or any network or anywhere in any location, you can able to do this kind of automations. So there is no limit at all. Okay, in the case of your IoT, the only thing is that you have to know these things are automated, right? So that is the only requirement. But if you think that can be automated, automatically it will be done in IoT. Okay, so that kind of very good technology that we have now. And for understanding this IoT, we are in need of some terminologies about the cloud computing. So as I introduced before, your cloud is nothing but a virtual location. But in the case of your cloud computing, we need to understand the three way of representing your cloud. Okay, so one is your IaaS, another one is your PaaS and SaaS. Okay, so as far as your CSE students are concerned, they will be having much idea about it. But in a nutshell, I will give you an idea about what is each and every terminology represent. Okay, so first we will start with our SaaS, where software as a service is a form of cloud computing, where your complete software application will be given as a service. Okay, so this is provided to the end user directly. So in that application, you can do whatever the things you wish to do, right? So for example, in that application, if you want to create a table or some kind of databases, it is easily done, or you can able to delete or add, insert, update, whatever the thing you wish, you can able to do with that software, where that complete software is available. Okay, your system is available, your platform is available, OS is installed, and your software is also installed, and only the thing is you have to log into the software and you have to create a new project and you have to work on that. Okay, so that simple it is. So this will be benefit to the users at the 100% level, because no need to have much idea about the your system configuration, your OS installation and everything. You just need instructions or the flow chart or how to do a project in that particular software alone. You have to understand or you have to study. Okay, so then you can easily done some IoT kind of project in that software as a service platform. And the second platform is that platform as a service, where the development tools or API libraries etc. will be provided by the cloud service provider, and the user have to build and manage the application, right? So only the platform will be available, right? So in that platform, you have to install your OS, you have to install your software, whatever that required for your service, and then you have to go for end user applications. Okay, so this is platform as a service. Suppose if one person is having some moderate level coding idea about this particular technology, having concept in IoT as well as in CSE, they can able to easily cope up with this particular service. And third important service is infrastructure as a service, where your virtual machine kind of support will be given. Okay, and the users will manage that machine, entire machine. They can able to configure whatever they want, and the users will select the OS whichever is convenient for their purpose. Either they can go with Windows or Macintosh or Ubuntu kind of things. Whatever the OS that they want, they can able to easily install and they can use it. Okay, right? Just like as pay as you use, right? And in that method they can able to use. So whatever the however number of hours that they were using that facility, only that amount will be charged from the user. Okay, but the user must know the entire thing, right? So how to know, install that OS, how to maintain that OS, and how to maintain the softwares, and how to do the programming inside that software, everything. Okay, from the scratch, everything he has to do. The only thing is they will give you a platform, right? The infrastructure they will be giving you, right? So because we cannot own that kind of platform or the virtual machine, because we don't offer 24/7 power supply, right? So, and 24/7 internet connection is impossible in the case of end user, but in the case of industry like Amazon or Google, they can able to offer this particular service without any problem, right? So that's the reason why users may prefer this infrastructure as a service from the scratch if they want to build up any cloud system, right? And one such cloud system is an Adafruit that we are going to discuss in more detail in the forthcoming days. And this particular cloud will give you a more customized kind of output, so that you can personalize more and you can do any kind of automation in a efficient way, right? And also we'll be having some paid clouds, right? So like Amazon, Azure, or Google Cloud and all will be a paid cloud, where depending upon your number of usage or number of hits, you will be charged. Okay, hit in the sense, either you may send your data to the cloud or you may get the data from the cloud, right? So for example, in the case of your temperature sensor, we will be updating the cloud with the temperature data. Here you will be publishing the data, right? That is also a hit. Okay, so one hit per second, in the sense one temperature data you will be sending per second. Okay, and if you are going to control your home appliances, right? So 10 number of times you are switching on your home appliances in 1 minute, in the sense, then there is a 10 hit. Okay, so likewise, depending upon the number of hits, you will be charged. Okay, suppose if you are not at all using that cloud for period of time, then only the base charge will be provided, but the number of hits may not be charged, okay, according to your need. So this you can easily impose to your customer, right? You can have a chart kind of thing, so that you can look into that cloud, which particular customer is utilizing this particular service more, right? So in the case of smart building automation, you can easily compare that which particular customer is utilizing that lift facility more. Probably that ground floor fellow cannot be charged more for that particular lift service, because it may not be used by that person. He is in the ground floor. Okay, so there is no chance at all for him to use that particular service. Even though he is using for 1 or 2 times, then that particular usage alone he has to be charged. Otherwise he may not be preferring that particular smart building, right? So likewise, for each and every floor, people will be charged accordingly. One fellow may be in the 10th floor, but he is not at all using that lift service, in the sense, why to charge him, right? So definitely it is not needed, right? The one who is utilizing more for one particular service, we can easily categorize in the case of the paid cloud. It is possible, but in the case of your unpaid cloud, there are some limitations. You will be given with some limited number of datas, right? So you, even if you send more number of datas, that will be ignored. Okay, the best example is Adafruit, where your number of hits will be limited to 30 per minute. Okay, so in a minute you can able to send either 30 data, or you can receive 30 data, or you can send 15 data and receive 15 data, likewise. Okay, either you may send or receive. Total number of data that can be accommodated in one particular minute is 30 only. Okay, not more than that. Suppose what will happen if you are sending the 40 data in 1 minute, in the sense, first 30 data alone will be accounted, okay, in the cloud, and it will do that particular action, and the rest of the 10 data, it will be ignored by your cloud. Okay, so this will happen in the case of your free cloud. But in the case of your paid cloud, all the data whichever that you are transmitting or receiving will be accounted, but it will be charged accordingly. Okay, so that's another one important thing you have to understand in the case of your paid cloud. And what happens if you are exceeding that 40th data, and if the next moment starts? Okay, for example, if I am sending 40 data in 1 minute to the free cloud, in the sense, especially the Adafruit cloud, 30 data it takes, okay, it does that operation, and 10 data it omits, okay, because the time exceeds, right? And after this 1 minute is over, in the second moment of time, it will accept that 41th data. 41th data to 70th data it will accept, because the next time slot will accommodate another 30 data. So likewise it will do the service. Okay, so very many clouds are available, like Adafruit, ThingSpeak, and your Blink cloud. So many things are there. I will try to cover all those things maximum possible. Okay, and I will also tell you how to make your own system or your own laptop or PC into a cloud. Okay, so that I have done it for you, and that also I will be teaching you for the in this course of period. Okay, so this will be something like your platform as a service, where you will be having your laptop, you will be having your OS, but by installing some software you can able to do the customize your software, and you can do some of the application on it. Okay, so this is called own cloud. Okay, so you will be converting your own machine into a cloud platform, right? So that is also work well, but if you connected with internet, and if you got some IP addresses, then definitely it will be globalized and you can access from anywhere. Suppose if you are not publishing your own machine, then automatically it will be limited within that region. That is, if you are having some LAN connection within that connected area only, you can able to operate. Or if you are having some Wi-Fi access, then within that area only it can be accessed, like what we are having in our laboratory. In our IoT laboratory, we have our own personalized cloud, but that cloud is not published, okay, in the cloud, but within the campus, anywhere from the campus, we can able to easily access our data. Okay, so that kind of things I will teach you. And only thing is, you have to publish it into a internet. Okay, if you have to get a domain name and you have to publish it, right? For that you have to pay some amount. After publishing it, you can access from anywhere from the world. Okay, so that is possible in this course. And next one is your characteristics of IoT. Okay, of course any particular technology will have a number of characteristics. So like our IoT is also having some characteristics. Okay, the very first characteristics is your connectivity. Okay, so I already told you, whatever the device or the sensors or the actuators that you are going to use, it has to allow us to connect easily, right? So we will be purchasing so many sensors, different company sensors from the market, and the sensors manufacturers may be different. Even for a single sensor, 10 kind of different manufacturers are there. Okay, even whatever the sensors that we brought from the market, it has to support our system, right? So our IoT system has to support for that, right? So that kind of connectivity we have to offer. So that has to be easily communicate with your controller with what we are using. Okay, in this case we are going to use Arduino or NodeMCU or something like Raspberry Pi. So for all these controllers, it has to support. Okay, it should not be understandable format, something like Chinese format, right? So both can communicate well, so that we can able to get the data or whatever the communication we send, that will understand and it will do that operation. So the better connectivity should be there for your IoT devices. And second one is intelligence and the identity, right? And we will be extracting some of the knowledge from your generated data. For example, if you are giving some temperature kind of data, you have to get some information from that. And if you are sending some picture data like an home security appliances, you have to understand what is that picture means. Without understanding that picture or without understanding the kind of data, then there is no need of installing this one. It is wasteful, right? So for that you need to add some intelligence. You have to have a knowledge, that is your system or your controller should have a knowledge to understand that particular generated data. It is very, very important. Okay, and also the identity. So it has to rightly identify from which which particular sensor the data comes, right? I may own some 4 cameras in my home. That may be one from my corridor, one for my briefcase, one for my veranda. Likewise, I may have a different kind of cameras, but I need to identify this particular picture is coming from which particular place, right? So if not, then I may be confused with my all those datas, right? So I should have a proper identity for each and every place. I will be having same kind of appliances, in the sense I should have a different identity. That is what I told you earlier, like IP version 4 or 5 kind of information or identity will be given to your IoT devices, called something like API keys, right? So with that identity, it has to communicate to your controller. So your intelligence and identity are the second important characteristics for any IoT devices. And third one is your scalability, right? So I can able to send 1000 data in a minute, or even one data in a minute, or one data per hour also, right? So depending upon the place in which I am going to apply that sensor, or depending upon the application in which I am going to use my IoT devices matters, right? So depending upon that situation, I have to go for either by doubling the scale or multiplying the scale, or I have to multiply reversely, I have to divide that scale, right? So scalability should be there. I have to accommodate for all this kind of massive amount of data. Okay, so whatever the sensors that we are using in our laboratory can able to send even thousands of data in one particular minute. Okay, so that kind of sophisticated sensors we have, but what is the use of getting that much amount of data for our training purpose, right? So it is not needed, right? So either we may go with some lesser kind of data, or depending upon the application, we have to go with some higher number of data. Okay, so that scalability it has to support. And next one is the dynamic and self-adapting, or the complexity, where you can use the one particular device for different kind of conditions, right? So one may be using in the morning or afternoon or at the night. So we may work with the different kind of conditions and different kind of lighting situations. It has to support it for everything, right? Suppose if I'm purchasing a camera that could only work during the morning, in the sense it is not going to be fully utilized, right? For 24/7 kind of automation, it is not going to be support, right? But you should have a night vision camera also. Suppose if there is a too much of sunlight, if there is a glaring effect, then automatically it is wasteful, right? So it has to support for different environment conditions, environment situations. So it has to adapt. It has to have some adaptability. That is a dynamic and self-adapting capability it should have, right? And it should have a proper architecture. Okay, so it is it should not be like a homogeneous nature, where I have to go only with one kind of manufacturer's component, right? I can get it from different manufacturers, and I can get hardware support from different industries too, right? So this could be cope up with your IoT project. Okay, otherwise it may not be useful. So architecture support should be there. And finally the safety, right? So we have to ensure that 100% safety. This is the only thing which we are lagging in our IoT, but somehow it is managed, right? Suppose if you are not going to publish into a public domain, then only if you know that particular device ID, then it is not vulnerable. It is not going to be vulnerable soon, right? You can able to access your own data. And also some personal data may be highly sensitive, like if you are keep on tracking one public figure, and then automatically it is a very big kind of problem for him, right? So it should not be done, right? So you should have some proper safety, and for that you should not be go directly into the net connection without encrypting your data. So for that you should have some end-to-end encryption, but of course it will add some delay, right? Because it will take some sufficient amount of time for encrypting as well as for decrypting, and also for accessing your data itself, it will have some more keys, right? So it will log into the system with some more keys, or some two-step verification, like what we are having in our Gmail account. Likewise it may have some future, so that may add some delay with your project response. Okay, so that's the only thing, but you can add some safety measures with your IoT projects. If you ensure all these 6 points in your IoT project, then that could be a best project for the user what you are going to design. And next one, IoT stack. Okay, so here in this IoT tag, I'm going to take one example and I'll explain you what and all the steps that you have to follow to create one particular IoT project. Okay, so here first step would be sensors input to the microcontroller. You have to choose the right sensor. Next one is processing and controlling action layer, so where your data will be processed, and third layer is your hardware interfacing layer, and fourth one is RF interfacing layer, and fifth one is your session or messaging layer, and sixth one is your user experience and visualization layer, and finally application layer. So these are all the six different layers that you have, seven different layers that you have to follow for any particular IoT project, so that the project would be in a efficient way to be used for your end user, right? So here we have taken an example of waste management, right? So that is this project aims to avoid the food wastage, right? So day by day, you know, 1/3 of the food may be 2/3 of the food may be wasted, right? All around the global, 2/3 of the food what we are manufacturing is completely wasted, right? It is not at all useful for any human beings. So that much waste that we are doing in every day, either it may be wasted before it is cooked, or it will be wasted after the cooking is over. So that kind of wastage we want to avoid, in the sense then it will be a billion-dollar business. Okay, so it is not a simple 100 or 200 rupees, it is million kind of dollar business that we can save. Okay, so for that we have come up with a simple solution. Okay, so for example, you assume that some potatoes were transported from Ooty to your Chennai city. Okay, so by using some cargo or some bigger lorries, they will be transporting from Ooty to your Chennai, and during the transportation time, you know very well, Ooty will be having some very less temperature, and Chennai will be the hottest one, right? So in our region, Chennai will be the hottest one. So during this transportation time also, so many vegetables will be getting rotten, and it is not at all going to be used by anybody else, right? So to avoid this particular problem, we have come up with a solution, like by placing some IoT sensor in that particular container, we can able to keep tracking of that vegetables quality, right? So as soon as the vegetable is going to rotten, we will identify it before, and we will informing this one to your driver. Okay, so how it was done, because we can have two things, right? So if any particular fruit is going to be a rotten, definitely that particular fruit will give you a bad smell, right? So the smell has to be identified at first. Okay, if it is going to be rotten, then definitely it smells bad, so we have to highly sensitive with the smell. So most probably the rotten fruits will give you something like methane gases, right? So it emits methane gas. So by identifying this particular gas, we can say that the fruit is going to be rotten soon. Okay, so this is one thing. So we have identified one sensor, and second important thing is that whenever you raise the temperature, right, the fruit's temperature is raised, then automatically it will be rotten, right? So you may seen that, right, in your box container. If you put one fruit for a longer period, right, 2-3 days, by closing that cap, if you are placing, then automatically the temperature may rise, and automatically the fruit may go into rotten, right? So in order to avoid this particular thing, we suggest with two sensors. One is your temperature sensor, and other one is your gas sensor, that is methane gas sensor. Okay, so temperature sensor, in addition, it will give you the humidity. Okay, suppose if the fruit is getting rotten, it may give you some bad smell, as well as some liquid will come out, right? So some water kind of things will come out, so that also will raise the humidity level. So temperature rises will be there, or otherwise humidity rise will be there. So by knowing this one, we can able to easily identify whether the fruit is in good condition, or it is going to be rotten soon, or it is already wasted, right? So likewise we can able to get a classification. So by using this concept, we can understand all these 6 layers, okay, 7 layers, okay. So first layer will be the sensor input, okay. So first we have to choose the right sensor for our application. Since the concept was well known, we know that the temperature sensor and your humidity sensor along with some gas sensor is required. So first we have to get a sensor, and we have to connect that sensor into the controller. In this case, our microcontroller would be something like a node MCU, right? It is not an Arduino. Suppose if you use an Arduino, what happens within that region only we can able to get the notification. That is, if you are near to that Arduino project only, it will give you some kind of information like either Bluetooth communication or something like beep sound. It will give you for identifying. But in the case of IoT, we have to access it from the remote location. For example, one cargo driver is carrying that vegetable from one place to other place. His owner must be notified with the quality of the fruit that he is carrying, right? So this should be done remotely. For that, definitely we are in need of an internet connection as well as the remote communication, right? So for that, definitely we are in need of a different kind of controller called a node MCU, right? And this would be easily connected to your cloud via his that is driver's mobile phone. And suppose if the driver is offering some hotspot connection to that device, that automatically it will be send information to the remote place. That is the vehicle owner or the vegetable owners may be informed about that quality of that particular fruit, okay. So first we have to choose the right sensor as well as the microcontroller. And second one is processing. After getting the data from your sensor, that microcontroller has to do some processing, where it has to understand with some prescribed given instructions, right? So what kind of instructions we give? So we will be giving something like temperature limit. So we know very well that fresh fruit will have some temperature. If it is in open air with some high quality place, then automatically it will be with some temperature, normal temperature, okay. And we have to identify the temperature at which your fruit is going to rotten, okay. So that limit we have to set it in our controller. Either it may be placed in the controller coding itself, or sometimes we may adjust the level from your remote location. That is, your vehicle owner may control from the remote location, or the vegetable owners may control, because we may carry different fruits may have different kind of temperature levels, the limitations, right? So for all these things, if you are having a single code in the controller, then again and again we have to program it. But if in the case of this remote programming or remote analysis, the customization can be done from the remote location, okay. Only your sensors will be received the information through your controller, okay. So this is also possible. So you have to go with some processing of your data, okay. After receiving the sensor information, you have to process. So by analyzing this particular range of values, we have to process the data. And after that, it has to give some right controlling applications, controlling actions. For example, one particular container alone will be having some rotten fruit, or it is about to rotten, in the sense automatically that notification may be sent to two people. For example, one to the owner, one to the driver. So what the lorry driver will do, automatically he identified that box in which some fruits were going to be rotten soon, and that particular box he will be pulling out from that container from the lorry, and he will be selling it to the nearby place. For example, in our case, from the Ooty to the Chennai, in the meantime in Erode or in somewhere in Salem or some other places, that he can able to drop that box. So even if he is selling for very smaller amount, that fruit is not going to be wasted. That is the thing here, right? So here, after wasting 2/3 of the food, we are getting it for 10 rupees, that tomatoes, right? Suppose if no fruit is wasted, you imagine the cost, right? So how much cheaper it is. So many people will be benefited, right? And nobody will be in a hungry stomach, right? So for that only we are proposing this. So definitely we should have some controlling action, that is via a text message or kind of information we can able to send to the driver. So that controlling and processing will be done in the controller. And next one is your hardware interfacing layer. After connecting this after doing this processing, so you have to interface this card things with your other hardwares, like you may actuate something like LEDs or some red light, you may blink it into your vehicle. So likewise we may give some different kind of hardware communications. And next we have to communicate this data to the cloud. So that is our next layer called RF interfacing layer, where different protocols will be there. For example, if you use some RF communications in the range of IEEE format, like your Wi-Fi or Bluetooth or NFC kind of thing, then it will take your data into the cloud. And before taking the data into the cloud, it has to be properly segmented. Okay, in the concept of internet itself, this segmentation will be there, where your entire data will be split into small packets, and it will be sent to the remote place one after another. Okay, and it will be having some proper head and its tail, and head will be having the information about that particular packet information, and tail will be having the next information, the next packet's information likewise, so that it will be connected in a proper format at the receiver side. So for that, so many protocols were suggested. We have MQTT protocol, CoAP protocol, HTTP, FTP, SFTP, SSH kind of things. And everyone knows that your MQTT is a lightweight protocol, where it carries very high information with small packet levels, and it is also not going to be time consuming for communicating with your remote server. So most probably that MQTT server would be preferred for your IoT communication. In our applications also, I am going to demonstrate with your MQTT protocol only. So after communicating this particular data through this particular protocol, then we will be having some user experiences, that is user interfacing layer, where user has to be given with some easy understandable format. For example, the lorry owner may not be educated well, or the lorry driver may not be educated well to understand what is happening inside the container, right? The kind of message that you are going to send it to the vehicle driver cannot be understand as you think, right? So you may be sending it via English or some kind of text that it is going to be rotten soon. Who will understand, right? Definitely not. So the driver has to be educated, or he can able to understand by seeing that message or seeing kind of a app. Okay, so for that we have to give some communication, proper communication. Either it may be like an so many containers in his lorry, and many green color symbols will be there, green color light will be blinking, and only in the container where the rotten foods are available has to be indicated with some red symbol. He can understand some numbers, right? So we can give some segmentation to your lorry, and each and every part will be imposed with this kind of sensor, and each and every part will be numbered, right? So if number 1 is blinking red, automatically the driver knows that particular container is having some rotten fruit. So or it is going to be rotten soon. Automatically he will get down and go into that right place, and he will be dropping that box in one particular place easily. So that kind of user friendly communication has to be established. Okay, so or otherwise we may give some voice notification. Okay, instead of sending the information in via this light blinking and all, he can able to make a call. It is also done, right? So many softwares are available to convert your text into voice. Okay, so with that we can able to call the driver, and we can say that this particular container is having some rotten fruit, so that he will be dropping that box in that nearby places. So this is also done. And next one is your application. The applications will be very important, where you can apply this particular concept in smart home or smart city, or in smart parking areas, or in smart energy kind of things. So which particular place that you are going to apply is very very important. Okay, so here in our case we are going for this food industry. Okay, so this is the largest industry, runs globally, right? So everyone needs food, so nobody is free from food. Okay, so definitely it is going to be a very good project, and the application can be given with some apps or kind of some website address or kind of something like your information message or callings, right? So likewise we can communicate to the people. So all these things will be simply mentioned in this particular figure. So first you will be notifying with the temperature, humidity and the sense of your gas to the from your truck driver, and it will be converted into a digital format. Of course all the sensors will understand the physical form of quantities, right? And after that, that will be converted into a digital quantity by using this ADC converter, which is inbuilt in your controller itself. And we will be having the controller, that is node MCU. This will be connected with your Wi-Fi. Okay, so definitely we are in need of internet connection via wired or wireless communication. So here in this case of node MCU, it supports for Wi-Fi, so we can easily connect it to the internet. Okay, so after connecting to the internet, we have to communicate to the cloud. So here in our case, your Adafruit is our cloud. Okay, so in this Adafruit we may have our username and password. So in that username and password, our data will be stored by using this controller, right? So this controller will have an access to this particular cloud. The username and password will be already given to this particular device controller, so it will be logging into your device cloud easily. And after logging into that cloud, it will post all those data, or it will get control from that particular cloud. And in order to save your data in the storage, either we may go with some Google Sheets also. So from the cloud, your one part of the data may be backup sent to the backup in your Google Drive itself. As I told you before, this particular free cloud may have some limitation. So in that case, we may go for backupping your code or backupping your data. Okay, suppose if you are using an Adafruit cloud, that they will be storing your data for 30 days. After 31st day, what happens? The first day data may be overwritten. Okay, you lose your first day data. Either you may download your data before 30 days, or you can save all those data the moment at which your data arrives into the cloud. Okay, so this is easily done with the help of IFTTT website. So they will be sending all your cloud data to the Google Drive, whichever the drive location you are sharing. And after that, we can go with some analysis, and by analyzing your data, we can communicate it to the mobile phone, either via app or something like call or text message or email kind of things. And the driver will also be given with some Google map too. So he will be knowing that in which particular place he has to drop that particular box. So this is also done, right? So if one particular box number 1 is going to be rotten after 1 hour, in the sense, he will be predicting earlier because of the sensor, that is your gas sensor. He can able to understand that it is going to be rotten after 1 hour. So nearby place he can able to easily track. So within his traveling path, wherever he finds some shops or some dealers, he can able to sell it to him. So for that, he can be communicated via the app also. So he will be notified with some marker that this particular box has to be dropped this particular place likewise. Okay, so that kind of information also will be done. So this is a best project that we have got an award of 5 lakhs rupees from Amazon Cloud, right? So and this particular project will be having all these layer concept. Okay, so that's why I have added this one. And next one is enabling technologies. Okay, so many technologies that you have to be added with this particular IoT, like technologies that may help in acquiring your data or sensing your data, or the technologies that may supporting you are analyzing your data, like your computer science people knowing so very many algorithms like machine learnings, deep learning, so many technologies were there, right? So that kind of technologies also it will support. I am reminding you again, the IoT is not only for your electronics or a computer science people, it is for all the engineering graduates, okay? Even for the layman it can be used. So much of different technologies it has. Even you may have a knowledge about how to code your website, how to code your own device or own server, or how to create your app, that also can be done. How to code your microcontroller will be taught, how to understand or how to configure your sensors can be taught. So many different variety of informations are available in this IoT. So by knowing this particular technology, you can have an idea about all these technologies. That is what listed here. So you can get an idea about how you are acquiring data from different sensors. That technology you can understand, and analyzing your data or processing your data, and also how to control your data or control your IoT devices. For that also we use different technologies. And also for enhancing the security or privacy also we will use some technologies. So many technologies were involved in this particular IoT. It is not a single unique department technology. And at last I would like to introduce this particular concept also called a big data, right? So big data in the sense we'll be having n number of sensors, right? So infinite number of sensors that we are connecting, about it is billions in count. So all these sensors will be sending some data. So the data may be in the form of anything like text message or voice message, or your picture, or it may be a video kind of thing. So many things, right? So we will be updating our selfies in our WhatsApp chat, or in our Orkut or something like that, right? So whatever the chat forums, Facebook kind of things are there. So we'll be publishing some redundant data, right? I would say that is redundant. Mostly 90 out of 100%, it is about 5 to 10% only informative, and remaining things will be wasteful, right? Something like YouTube channels, if you go 400 multiples of 400 times data will be added in an hour. Okay, so that many data we cannot able to process. So those things will be known as a big data, but it is not a big in size, and we don't have any limit for this. Okay, so big data in the sense you cannot say that 1 GB is bigger, or 10 GB is bigger, or 1 TB is bigger, likewise. Okay, so we cannot say it in number, but if your processor cannot able to handle all those data in a one particular shot, it will be called as an big data. Okay, I will tell you with an example. For example, if you own a mobile phone, okay, so that mobile phone will be having some 1 GB RAM, you assume, okay, and you are trying to copy some 4 GB film in it. Okay, so if you try like that, then automatically what your mobile phone will do in the sense, first 1 GB data it will put into it will keep into that RAM, and then it will process. Either it may be copying, or it may be moving from one place to the other place, or whatever the thing we are doing, it is a kind of process. But for all these process, we have to have our data in the RAM at first. Okay, then only your processor will do the operation on it. Okay, so first out of 4 GB film data, first 1 GB data will be processed, and second 1 GB data will come into act, and third 1 GB, and fourth 1 GB. Likewise, it will take 4 cycles. Let us assume for our better understanding, it takes 4 minutes. Okay, 1 GB data is copied in 1 minute, you assume. So 4 GB data may be copied in 4 seconds, 4 minutes. Okay, in this case, suppose if you try to copy the 16 GB film, then automatically it takes 16 minutes, right? So this is definitely an overloading of for your mobile phone. So this is very big data for your mobile phone. Even more than 1 GB data is considered as a big data for your 1 GB mobile phone. The same mobile phone, if you try to copy with 500 MB data, okay, your RAM size is 1 GB, you are trying to copy with some 500 MB, that is half GB data you are trying to copy. What it will do? Easily it will take the data, and it will process, and it will give you an output. Okay, so this is an immediate process. In this case, it is not a big data for your mobile phone. Okay, for that 1 GB mobile phone, it is not a big data. Then you take another one example that you are having some 16 GB RAM size and you are trying to copy 1 GB data. Okay, it is GGB for that. Okay, so it will instant of moment it will process the data, and if you go with some 4 GB film copying, also it can be done in 1/4 of the time, that is 15 seconds it will do. Suppose if it takes 1 GB to 1 minute, in the sense in 15 seconds it will do the copying. And if you take 16 GB data for that 16 GB RAM mobile phone, then it takes in 1 minute. Okay, complete that operation. So likewise, depending upon your server, we can say whether the data can be processed in one particular shot or it needs multiple cycles. Okay, that defines whether the data is big or small. Okay, so here in this case, definitely I would say whatever the processors or the controllers available globally, it cannot able to process all those data which is available globally. Even your YouTube data cannot be analyzed, right? But we can analyze the data after a few moments or multiple number of cycles only we can able to analyze that particular data. Okay, so this is called big data. I think you may got some idea about it. So for any particular big data, you will be having some uh, characteristics like 3 or 4 V's we can represent. So first characteristic is scalability, that is in volume. Second characteristic is complexity, variety we can say, and third characteristic is velocity, and fourth one is veracity, that is data in doubt. So what is meant by scalability? In the sense, huge volume of data that is generated every minute, but storage has become cheaper, hence we are surviving nowadays, because we are getting different format of data from different sensors. So we have to allocate some storage device for that particular data. So that's why it is a volume is a main characteristics. Second one is your variety. We may get some different format, that is audio format, text format, video format, and many image format, many things, right? So different varieties we have, different volumes we have. Volume in the sense, in a minute we can send 1000 data, or in a minute we can send some few to 10 number of data, right? And we can have some velocity too, that is, if one who is owning that 3G connection or 4G connection, they may load more, and if those who have only 2G data, they may load less. So depending upon their data speed, you know, they can able to load the data. So they also going to contribute for your big data. And next one is veracity, that is the nature of getting changes quickly into the ambient scene, that is incomplete data, right? So that will also another one kind of big data. So these are all the major possibilities. And where we can generate data, in the sense, sensors from various security systems, or sensors from your weather monitoring system, or car navigation system, water quality monitoring, something like wearable devices in your hand, or your industrial equipments, or your bridges, or your media, everywhere, right? So whatever the device that is IoT device that we are going to connect it to the cloud, either it may be useful or useless, something data it is going to send into the cloud. Okay, so that is the thing. So if you analyze the data all together at one sort of operation, then it cannot be a big data. But if you cannot able to handle the data in one particular cycle, then definitely it is a big data for your machine. So it is not like an big data is not an big magic, right? Doesn't matter how much data that you have if you cannot make it sense of it. Of course, this is a valid sentence, because if you do not have some useful information from the updated data, it is utter waste, right? So with this, I would like to conclude today's session. Again, healthcare only. So this we already discussed.